Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Bakar. We're on Unit 8, Video 2, inverse functions and relations, but it's mostly inverse functions that we're going to be dealing with. Learning target, I can find the inverse of a function or a relation. Okay, couple of things. A relation is a set of ordered pairs. Given the relation 1, 2, 3, 4, and 5, 6, identify the following. Domain. Domain is basically your x values. So using set notation here, 1, 3, and 5. And our range would be the y values. We've done this before, 2, 4, and 6. There we go. So just identifying domain and range. An inverse relation, okay, is a set of ordered pairs found by flipping the x, or switching the x and y values. So the inverse of this relation right here, flipping your x's and y's, you have 2, 1, 4, 3, and 5, 6. Oh no, I'm sorry. This is 5, 6, so flipping x and y's would be 6, 5. And that's the inverse of that relation. Okay, so showing you something a little bit here. The ordered pairs of a relation, 2, 1, 5, 1, and 2, negative 4, are the vertices of a right triangle. Find the vertices of this relation and then graph the two relations. I'm going to graph this one first in blue before we find the inverse relation. 2, 1 is this point right here. 5, 1, 1, 2, 3, 4, 5, 1. And then 2, negative 4. 2, 1, 2, 3, negative 4. So there is a triangle, okay? And what I want to show you then is how inverses are related to each other. And they're kind of related to us with the identity function, which is f of x equals x or y equals x. That's the identity function. If you were to graph y equals x, your slope is up 1 over 1 and your y-intercept is 0. So it's kind of going right through here. This is the identity function. And inverses of each other, you can usually flip over this line right here. So we'll see. We'll graph this inverse of this relation. First of all, what is it? Flip the x's and y's, so 1, 2, 1, 5, it's very easy to find, and then negative 4, 2. Okay, so 1, 2. 1, 2 is this point right here. 1, 5 is this point right here, and then finally negative 4, 2. There they are. If you take this triangle and flip it over the identity function, you get this triangle right here. It's inverse function, or inverse relation, I guess you'd say. Okay? That's how inverses are related to each other. Okay, it says find the inverse of function f of x. The inverse of function f of x is f inverse of x. This little negative 1 up here means it's the inverse function. There's a couple ways to write these. We're not always going to write it in this form, but I'll show you how to write it in that form if you were going to write it in that form. If f of a equals b, then f inverse of b equals, f inverse of b would equal a. So basically, if you take this function and you find the inverse of it, you're flipping your x's and y's around. So, it says find the inverse of the function f of x equals x plus 1, or x plus 2. First things first, f of x is the same as y, so this is y equals x plus 2. And now you can start finding the inverse. It's solved for y right now. The inverse of a function is to solve for the other variable. In this case, our other variable is x, so we're just going to solve for x. Now the way we do that is just subtract 2 from both sides. So y minus 2 equals x. And you can leave your answer just like this. I think it's better just to not write it in the f inverse of x form. I'm going to show you how to do that in a second here. So definitely just leave it like this. Then you know what your variables are and you're working with x and y. But if I was going to write, instead of f of x, f inverse of x, this is what you do. It says y minus 2 equals x. You switch the x and y's around. So instead of y minus 2 equaling x, y would equal x minus 2. So my inverse function, I just put x in here for y, it's x minus 2. So there's my inverse function. I'd rather have you write it like this, but this is how you would write it using the inverse, f inverse of x. So what's the big deal with that? Well, here's why. It says find the value of f of 5, and then find the value of f inverse of negative 7. You kind of see something here. So our first function there is f of x equals x plus 1. So I want to find f of 5. Plug 5 in for x. I get 5 plus 2, or 7. So basically they're saying when you plug 5 in for x, you get 7 for y. Now in the inverse function, they want us to plug in negative, or 7. So when I do that, f inverse of 7, I get 7 minus, plugging 7 in for x right here. 7 minus 2, that equals 5. So that ordered pair, when I plug in 7, I get 5. And if you can see this, they're inverses of each other. So that's the inverse function. So practicing on finding the inverse function. First thing I would do here is plug in a y for f of x. Y equals x plus 6 minus 2, or I'm sorry, divided by 2. So now, to solve for y here, I got to get x by itself. I got to get rid of the 6 and the 2. You're going to get rid of the 2 first because I can't really get to the 6 until I get rid of the fraction part of this problem. So I'm going to multiply both sides by 2. That's the same as 2 over 1. These cancel out. And I get 2y. 2y equals x plus 6. Now to solve for x, I just subtract 6. And finally I get 2y minus 6 equals x. This right here would be perfectly fine. That's the inverse function. You're solving for the other variable. But if I was going to write it as f inverse of x, remember you have to switch the x and y's around. So instead of saying it's equal to 2y minus 6, it's 2x minus 6. And that's just so you can do the inverse part of it with the ordered pairs. But this is perfectly fine for me. And when you're working with real world problems, you're not going to switch the variables around anyway. And we're going to be getting to those in a little bit here. Find the inverse of f of x equals 5x plus 10. So first things first. Change that to y. And start solve. Right now it's solved for y. The inverse function would be to solve for the other variable. In this case, it's x. So we're going to subtract 10. I get y minus 10 equals 5x. And then finally, in this case, we just divide both sides by 5. Not just the 10, but the whole thing. Divide by 5. So I would say your final answer is just this. X equals y minus 10 over 5. And we're done. Very good. Okay, determine whether f of x equals 3/4 x minus 6 and g of x equals 4/3 x plus 8 are inverse functions of each other. This is where we go back to composition of functions and the identity function, which is this, y equals x. Because what we want to do is either plug the g of x function into f of x or the f of x function into g of x, composition of functions, and see if we get this. If you say we'll take f of g of x, you want to get the identity function, just x for your final answer when you simplify it. If you do, they're inverse functions of each other. The book says you have to do it both ways. I'm just going to say you have to do it one way, and that's fine. So we want to find this, f of g of x, and we want it to equal x. If it doesn't equal x, they're not inverse functions of each other. So here we go, f of g of x. What is that going to equal? Well, I'm going to take the f function, I'm going to plug the g of x function into the f function. What is g of x equal to? Right here. 4/3 x plus 8. And I'm going to take that function and plug it into the f function. So the f function is this, 3/4 times x minus 6. Okay. So what am I plugging in for x in the f function here? The g function. 4/3 x plus 8. Okay. So using the distributive property and simplifying this, 3/4 times 4/3, well that's 12 over 12 or 1. So that's 1x plus 3/4 times 8, well that's 8 over 1. That is 24 over 4 or 6 minus the 6 over here. Simplifying it down, 6 minus 6, they cancel out, and you're left with x. Well, that means f of g, or fog, of x equals x, which is the identity function. So they are inverses of each other. Another way you could do this is by plugging in some ordered pairs if you wanted to, but you'd have to do more than one set to make sure it works. So composition of functions, plug one into the other and make sure you get x. You could also maybe do it this way. Plug a number in for x, and you want it to be divisible by 4 because you're multiplying by 3/4. I'm going to plug in 4 and see what you get for y. So y equals, f of x is the same as y, 3/4 times 4 minus 6. This becomes 12 over 4, or 3, minus 6. This is negative 3. Okay, so 4, negative 3. So what that means is we should have a point negative 3, comma 4 for the other function. I'll do that in blue here. Once again, g of x you can just say as y equals 4/3 times negative 3 over 1. Same as negative 3 plus 8. We get negative 12 over 3, which is negative 4 plus 8. Negative 4 plus 8 is 4. So there we go. We have two ordered pairs. We start by plugging a number in for x in the first function, and then plugging that y value in for x in the other function. They should be opposites of each other. You can just flip them around. So it does work. They are inverse functions of each other. However, if you use this method, you should use one more than one point. Like maybe plug in 8 and see what you get. And make sure it works with the other function then. Okay? If you have questions on this, ask me tomorrow. I can explain a little bit more. Here we go, number 5. Here's a real world problem. A of r equals pi r squared. Well, that's area of a circle. So first thing I would do with this is I wouldn't work with a of r. I just say area equals pi r squared. Now, they say find the inverse of this function. Well, if you want to find the inverse, you want to solve for a different variable. Right now it's solved for a. The inverse function, pi is not a variable, but r is a variable. So I'm going to solve it for r. First thing I would do is get rid of the pi. So I divide both sides by pi. You're multiplying here, pi times r squared, so to get rid of it, you would divide. So area over pi equals r squared. The opposite of squaring something would be to take the square root of it. So I'm going to take the square root of both sides. So that means the square root cancels out the square. R equals, and you can just leave it like this, the square root of a area over pi. This is the inverse function of the original function. Now, what does this help us with? Well, it allows us to come up with, you usually want to plug in a radius and find area. Now I'm saying, well, maybe you know the area, and it would be pretty easy to find the radius by just plugging area into this formula and then solving for r. And that's what they want us to do here. It says, find the radius of a circle. with an area of 314 centimeters squared. Well, that means R, because it's solved for R now, and that's what we want to find, equals the square root of 314 divided by pi is 3.14. So R equals, if you divided this out, it'd be the square root of 100, or in this case, 10. So our radius for the circle must be 10 centimeters. Very good. And you might get 9.9 if you divide by the pi symbol on your calculator. 9.9 rounds to 10 pretty easily. So we're good. Let's go to this one. Now, here you see a little table comparing Fahrenheit and Celsius degrees temperatures. The United States is the only country that uses Fahrenheit. So most countries, all countries use Celsius. So a lot of times we have to convert from Fahrenheit to Celsius. Now this is a formula for that, to convert from Celsius to Fahrenheit. I'm not going to use f of x. We're just going to call it f for Fahrenheit. Equals 9/5. I'll say C for Celsius, because that's what this x would be right here, plus 32. They want us to find the inverse for this. I'm definitely not going to work with f inverse of x. I'm just going to solve it for C. And that would be the inverse of this function. Right now I could plug in a Celsius temperature, multiply it by 9/5, add 32, and that would be Fahrenheit. What if I had Fahrenheit and I wanted to find Celsius? Well, that's when you'd want a different formula. So we're going to do this. Subtract 32, start solving for C, the other variable. I get Fahrenheit minus 32 equals 9/5 C. Now there's a couple different things you can do here. Let me get rid of this thinking guy. A couple different things. I could just multiply both sides by 5/9. But you're multiplying it by this whole thing, so it should be in parentheses. So this would be 5/9 times Fahrenheit minus 32 in parentheses, and that would be what C is equal to. That's one way you could do it, and that would be just fine. I would probably do this in a couple steps. Still going to have to do it to the whole thing, f minus 30. I would multiply by 5 or 5/1, and that would cancel out this 5, and I'd be left with 9C. And multiplying this side by 5, I'd just have that. 5 times, actually, I might multiply it through. No, I'll probably just leave it like this. F minus 32. You could distribute the 5 through, and that would be fine. I'll probably look a little cleaner, and then just divide both sides by 9. So the Celsius, or the inverse of the Fahrenheit formula, is 5 times F minus 32 all over 9. So the first way I did it, or this way, would be just fine. Just make sure you don't forget your parentheses. And that's it. If you have any questions, don't be afraid to ask some questions tomorrow. Peace out. You're all Scout.